So let's do an example of a quadratic form. So I've got the following: x to the 6th plus 7x cubed equal to 8. And just like really any equation where you have powers of x that are something other than 1, right? If you have a non-linear equation where you have x to a higher power, we almost always want to bring everything to one side and factor. So just like every other time, unless you're solving something like 3x plus 2 equals 0, right? In this case, that's where you want to solve for x. In this case, you want to factor. So I bring everything to one side. So you get x to the 6th plus 7x cubed minus 8 equals 0. And the idea here is that this particular thing, where you've got 1, 2, 3 terms, is often called a trinomial, because you've got 3 terms and it's a polynomial. If you notice that the bigger power is twice the smaller power. So my biggest power is 6, my other power is 3, and if this one is twice that one, then I can factor this in what usually looks like how we factor a quadratic thing. And you can do this in one of 2 ways, and either way I'm fine with. One way is just to factor it. You can say, okay, I know I'm looking for numbers that multiply to -8 and add up to 7. And there are numbers that do that. They are +8 and -1. So I'm looking for something like, so this is actually, I was going to do it the fast way, but I just kind of realized this is a really good opportunity for us to do it, breaking this up into the 2 pieces and factoring by grouping. So I'm going to do that instead. So I'm actually going to show you 3 ways to do this one, because there's 3 ways you can do it. So one of the ways, we can say, hey, this is x to the 6th plus 8x cubed minus x cubed minus 8 equal to 0, right? I broke up 7 in as, right, 7x cubed is 8x cubed minus x cubed. And then I'm going to factor by grouping. So the first 2 pieces, I factor out an x cubed. I'm left with an x cubed plus 8. The second 2 pieces, I factor out a -1. And I'm left with an x cubed plus 8. So, here, oh, she went away. I was going to let her in. Come back. All right, lost her. Sorry, this is equal to 0. So then we can factor out the x cubed plus 8 from each piece and get x cubed plus 8 times x cubed minus 1. She keeps coming and leaving it. I don't know what's going on. That's one way you could do it. The other way you could do it is you could just see that it factors, right? Like you don't have to go through this whole long process. You just be like, hey, I see that we're multiplying to -8. We're adding up to +7. You could just go straight from here to there, and that would also be fine. And then before we find the answers, because we're not quite done yet, there is one other way you can do this. And this kind of depends on your preference. I'm perfectly good with you doing it this way. In fact, when I think about it more, I kind of think this way I just did it might be the best way if you don't just see it right off the bat. So I kind of like this. You can also just see it. And then there's a third thing. There's what we call U-Substitution. So
I have a question.
Oh, go ahead. Yeah, go ahead.
I'm very confused on how you got the 7x cubed to be 8x cubed minus 8.
So I've got the 7x cubed as 8x cubed minus x cubed.
Oh, okay. That makes, okay, thank you.
Just as a reminder though, the way I got those numbers was I saw that let me use a different color here. I saw from this that my A times C was 1 times -8, which is -8. So I was looking for numbers that multiply to -8 and adding up to positive 7. And I see that negative 8 plus 1 is equal to negative 7. So, positive 7, not negative 7. I mean, this is true, but I want to add the positive 7. So I saw that 8 plus negative 1 added up to 7, and that's how I got those numbers there.
Okay, thank you.
You're welcome. Good question. The other way to do this, which is not required at all, but if you wanted to, you could say, okay, I've got x to the 6 plus 7x cubed minus 8 equals 0. And then you could let u equal x cubed. And then if you square both sides, u squared is x cubed squared, which is x to the 6th. And when you do this, your choice for u should always be the power that's closer to 0, and u squared should always end up being the other power of x. So if you have a u and a u squared, they should match up with the things you have. And then you just rewrite this. You can write this as u squared plus 7u minus 8 equals 0. So then u plus 8 times u minus 1 equals 0. So then you get u equal to negative 8 and u equal to 1. Now the thing about this that's easy to kind of make an error doing is to forget to finish it. So we got the u equals negative 8 and u equals 1, but we're not done, right? I wasn't asking what the solution for u was. I was asking what the solution for x was. So I should go further and say, oh, well, look, we said that u is actually x cubed. So I have to plug that in to solve for x. So I'm really solving x cubed equal to negative 8 and x cubed equal to 1, which is the same thing we would have gotten if we had done it this way, right? If I set this equal to 0, I get x cubed equal to negative 8. If I set this equal to 0, I get x cubed equal to 1. So all I'm really trying to show you here with this example is it doesn't matter which way you do it. Eventually, as long as you're doing the right things, you will get to the same place, whether you do it this way or the other way. So to solve this, we can just take the cube root of both sides, or the 1/3 power, either way, right? You can say that x cubed to the 1/3 equals negative 8 to the 1/3. And the 1/3 power of negative 8, or the cube root of negative 8, is just negative 2. And x to the 3rd to the 1/3 is just x. Same deal over here. X to the 3rd equals 1. The cube root of x cubed equals the cube root of 1. I'm really writing the same thing, just different notation. Cube root of x cubed is x. The cube root of 1, or any root or any power of 1, is also equal to 1. So those are my solutions. X equals negative 2 and x equals 1. And these are the only real solutions to this equation. Sometimes, I don't want to say that. Okay. But I have to admit, I'm really kind of a fan of the way we just did it with all this. I kind of like this the best. That doesn't mean you have to do it the way I like to do it, right? You can do it whichever way you like the best. But I might try and do more of it this way, because I kind of think this works out pretty nicely. And you don't have to do, I personally find doing this U thing, I don't know, it's not bad, I just don't like it. I will also point out that we call this U-Substitution, but in Calc 2, when we do integrals, there's a different thing we also call U-Substitution. So it's kind of, I don't love having the same name for two different things, but that is often something that happens in mathematics, and you kind of have to get used to it. But usually the other, like if someone just said U-Substitution, most of the time they'd be thinking of the Calc 2 U-Substitution, not this U-Substitution. Let's do some more examples. X plus, and please feel free to stop me with questions if you have them. It's a good question. X plus 12 equal to 7 times the square root of x. And so I'm going to do two things. I'm going to bring that over to the left, I'm also going to rewrite it as a power. I really don't want roots if I don't have to have them. So I'll write this as x to the first minus 7 times, not the square root of x, but x to the 1/2 plus 12. I feel like I might have made a mistake. It's all right. Sometimes I make mistakes. No, I didn't. I'm getting ahead of myself. I didn't make a mistake. I just thought I did. So, and I wrote x to the 1, even though I didn't really mean to, but I want to really point out, right, that here I have x to the 1, here I have x to the 1/2. This power is twice that power. So we can see that, oh yeah, it's looking like a quadratic form. And I really think I want to do it the other way. So I'm looking for things that multiply to 12 and add to -7. Well, that's going to be -3 and -4. So in this case, I'm going to write this as, so, well, no, I'm not going to do anything special. I'm going to write this as x. I'm not going to write to the first power. We know it's to the first power. And I'm going to write the -7 times x to the 1/2 as -3 times x to the 1/2 -4 times x to the 1/2 plus 12. And this is where we have to be a little extra careful, I think. So maybe I will write the x to the first. Okay, so let me ask you guys, from this first pair of things, what power of x can I factor out? You can't really use your fingers because it's a fraction. So you could do. Say it again, I missed part of it.
X to the 1/2.
Exactly. And it's always going to be the lower power, right? If you've got powers of x added or subtracted together and you're factoring out x to the something, you're always factoring out x to the smaller power. So I'm going to factor out x to the 1/2 or divide out x to the 1/2. So when I divide out x to the 1/2, 1 minus 1/2 is 1/2. Red pen. And then from the, well, geez, red pen all over my hand. Okay. And then from the -3 to the 1/2, I'm left with a -3. And then from here, all I can factor out is a 4 or a -4. And I'm going to pick -4. So I factor out a -4 and I'm left with x to the 1/2 -3. So let's see. Factoring out the x to the 1/2 -3, and they are the same, so I can factor by grouping. You're always going to be able to factor by grouping if it's this kind of deal. If we're using this method, you're always setting yourself up so that factoring by grouping will work. As long as you can multiply to this and add up to that. So x to the 1/2 -3 times x to the 1/2 -4 equals 0. And I've been inefficient with my board space here. I would like a little of it back. So then, just like we've been doing before, when we factor, so a lot of times, right, like if you have x -6 equal to 0, you say x equals 6, and you don't really write it down. But here, I think it's really going to be in our interest to write each factor equal to 0. So I'm going to set x to the 1/2 equal to 0. Sorry, x to the 1/2 -3 equal to 0. And then x to the 1/2 equal to 3. And then I'm going to square both sides. So that x to the 1/2 squared, which is just x, is going to equal 3 squared. So that x is equal to 9.
Mister, wouldn't you do the square root?
I would not do the square root. So here's what this equation says. That's a really good question. So when I'm writing x to the 1/2 here, I'm writing, it's the same as writing the square root of x is equal to 3. So to undo a square root, I have to square both sides. Well, and we'll see another example. If it was like x squared equal to something, then you would square root both sides. So you're always trying to do the opposite or the inverse kind of power of what you want. In fact, what I really am thinking when I'm thinking of squaring both sides is I want the reciprocal of whatever that power is. So here I get x equal to 9. And then same deal, x to the 1/4 minus, sorry, x to the 1/2 minus 4 equals 0. X to the 1/2 equals 4. X equals 4 squared. X equals 16. Those would be my two solutions. Sometimes, depending on the powers you were dealing with, you might have to check your solutions because occasionally you get what are called extraneous solutions, where although they seem like they're a solution, they actually aren't. Here, we don't have any extraneous solutions. If you plug back in both of these, if you plug in 9, 9 plus 12 is 21, and 7 times the square root of 9 is 7 times 3, which is 21. If you plug in 16, 16 plus 12 is 28. 7 times the square root of 16 is 7 times 4, which is 28. So here, both of our solutions are perfectly valid. But there are occasional times when you get solutions that are not. And I am fairly certain I didn't write any of those on your homework. But again, especially with that one assignment, if you think there's an error, don't hesitate to get in touch with me. Here are two such examples where you might have either problems with having solutions or having extraneous solutions. And I'm just coming up with these off the top of my head, but actually, yeah, let's go with that. Let's go with that one. Come back to you. Yeah, cool. So here's a similar equation to the one we just did. I don't want, I've changed my mind. I'm going to change up a tiny, tiny bit. Let's do this one instead. I want that to that. Okay, let's do x. Yeah, okay, I'm smart. I'm sometimes smart. Plus 3 square roots of x equals 4. Let me double check I'm not doing something wrong. Yeah, cool. Okay, so I'm going to point out, no, I'm not going to point anything out. I'm going to make sure my math works. Sorry. Yeah, okay. Yeah. Okay, good. So in fact, I want you guys to work on this one on your own for a minute. So I'm going to kind of write stuff slowly and not say any words, but I'm going to give you a minute head start. So go ahead and start working on it while I go refill my water. So bring the 4 over, right? This is x to the 1/2. Look for things that multiply to -4 and add up to +3. There's only like 2 choices. So hopefully people were able to get to here without too much trouble. Let me explain my steps just to make sure we're all clear. Brought over this, rewrote that. Numbers that multiply to -4 and add to 3 are +4 and -1. Broke this apart in the usual way, right? I rewrote 3x to the 1/2 as -x to the 1/2 plus 4x to the 1/2. If you did these in the other order, that is also perfectly fine, right? It doesn't matter which order you add these together. You can do +4 - 1, or you can do -1 + 4. Either way is good. Then we factor by grouping. From here, I factored out an x to the 1/2. From here, I factored out a +4. Each one left me behind with an x to the 1/2 - 1. X to the 1/2 - 1. And then from each of these two larger pieces, I factored out the common factor of x to the 1/2 - 1. Brought that up front. This piece left me with an x to the 1/2. This piece left me with a 4. And now I'm going to set them each equal to 0. So I'm going to set x to the 1/2 - 1 equal to 0. I'm going to add 1. I'm going to square both sides. X to the 1/2 squared is just x. 1 to any power is 1. Now I'm going to do the same thing here. X to the 1/2 plus 4 equals 0. So x to the 1/2 equals -4. Square both sides. X to the 1/2 squared equals -4 squared. And somebody tell me, what's -4 quantity squared?
16.
Yeah. And just for emphasis, I'm going to say +16. Sorry, that should be x, not x squared. X is equal to 16. Okay, now here's the deal. In this particular example, right, it's not, sometimes you're going to have every solution's fine. Sometimes actually none of your solutions might be fine. In this particular example, 16 is not a solution. It's an extraneous solution. How do we see it's not a solution? Well, if I plug 16 back in, 16 plus 3 times the square root of 16 is 16 plus 3 times 4, which is 12, and 16 plus 12 equals 28, which is not 4. So that's an extraneous solution because it's not a solution to the original equation. And really what happened was right here, the square root of x, right? We have talked about how the square root always ends up giving you a positive answer, right? You can't take the square root of something and get a -4. So this is why we're having a problem, because we need the square root to equal -4, and it doesn't ever equal -4. So that's why 16 is an extraneous solution here. I don't want to spend too much time harping on this because while it does come up on occasion, it is really not the most important thing to be concerned with here. But I just want to point out that occasionally you might need to check an answer. I think on the homework there might have been a couple of them that say like check your answer. So just be aware that there are 1 or 2 of these where things are a little wonky. Let's do one more example. Yeah, there is another example in the notes that I'll post up today where there is no solution. In fact, you can work on this one on your own if you want. It is x plus 3 times the square root of x equal to 2. -2, sorry, equal to -2. If you want some extra practice, you can do this one. And then you can look at the solution on page 1, 2, 3, on page 4 of the notes that I will post after class. So that's good practice if you want. Here's one more. And then we'll do some quick graphing. Yeah, I got 10. Okay. So 2x to the negative 2/3 plus 5x to the negative 1/3 equals 3. Now I want to solve this one. And so if you look at my, so I don't want to say that. We do the usual thing. I'm going to say 2x to the negative 2/3 plus 5x to the negative 1/3 minus 3 equals 0. And there are a number of ways you could go about doing this one. Personally, I'm going to do what we've been doing. So this one's a little more complicated, right? Because I have a 2 here instead of a 1. So I have to actually kind of use the method of factoring by grouping anyway. So I'm going to say a times c is 2 times negative 3, which is negative 6. I'm looking for numbers that multiply to negative 6 and add up to 5, which I always feel like I'm going to blow it when I do this. So let's be careful. When I multiply to negative 6 and add up to 5, that means my numbers are going to have to be positive 6 and negative 1. That's the only way to multiply to negative 6 and add up to positive 5. Okay. So then we're going to rewrite this term as negative x to the negative 1/3 plus 6x to the negative 1/3. This is where something I said before isn't going to be exactly true. It's a small thing, but it is a thing worth noting. So
Do you have to flip the two middle numbers?
you don't. You can, but you don't have to. So I'm going to do it this way to kind of point out that you don't have to. But yeah, in fact, I would probably normally have written it the other way because that feels more normal to me. But here I'm going to not. So what can I factor out from each of these? I can factor out an x to the negative 1/3. Now I have to be extra super duper careful. No, that's fine. This is, This is, no, this should be fine. Sorry, with negative numbers, things are a little weirder. I think we're fine, but I'm always worried we're not. So when I factor out an x to the negative 1/3, I'm left with a 2x to the negative 1/3 minus 1. This feels weird to me. So I'm going to do some checking real quick. If I multiply these back together, what would I do with the powers? Add, subtract, multiply, divide.
Multiply.
You'd add.
Yeah, so I'd multiply if it was a power to a power, right? Like when we do the x to the 1/2 squared, then we're multiplying those powers and getting x to the 1/2 times 2, which is x to the 1. But here, since we're multiplying things with the same base, we add the powers. And negative 1/3 plus negative 1/3 does give me negative 2/3. So good, I feel safe, right? I definitely checked and it makes sense. We do the same thing here. Well, a similar thing. I'm going to factor out the greatest common factor, which in this case is just 3. So I'm left with a 2x to the negative 1/3 minus 1. Good, and these are the same, which is always what you're hoping for, right? If they're not the same, you need to go back. So then we pull the same thing out. So we've got a 2x to the negative 1/3 minus 1 times an x to the negative 1/3 plus 3. Okay, and now I really want more room, but I don't want to move the side of the thing. So I'm going to erase some of this top equation. If that's, no, I can be fine. I can be over here. So we're going to set each of them equal to 0. Let's do this one first. So I set x to the minus 1/3 plus 3 equal to 0. I'm going to solve that like we usually do. X to the negative 1/3 equals negative 3. And then what power do I need to raise both sides to so that I'll get the power, so I'll get x to the first? What's the reciprocal of negative 1/3?
-3?
Yeah, it definitely is negative, right? So whenever you're taking a reciprocal, you're always going to get the same sign. So if your number is positive, its reciprocal is positive. If your number is negative, your reciprocal is negative. Just like the trig functions, right? We saw the reciprocal trig functions always have the same signs as the originals. Same idea. So then x to the negative 1/3 to the -3 is x to the negative 1/3 times -3, which is just x to the 1, or just x. -3 to the -3 is 1 over -3 to the +3rd. And -3 to the 3rd power is -3 times -3 times -3, which is -27. Or as I would write, -1 over 27. The other answer, which I am going to erase now so we can get it. So this part equal to 0. 2x to the negative 1/3 minus 1 equals 0. I'm going to solve for x. 2x to the negative 1/3 equals 1. X to the negative 1/3 equals 1/2. And then I'm going to raise both sides to the negative 3rd power. So this left side just becomes x. And if I was doing 1/2 to the negative 3rd, I might think of that as 1/2 to the negative 1 to the 3rd. Because 1/2 to the negative 1 is just 2. And 2 to the 3rd is just 8. And if you think about it, if you plug that back in, it totally makes sense. If you plug 8 back in here, the cube root of 8 is 2. So x to the negative 1/3 power is 1 over 2. And 2 times 1/2 is 1, and 1 minus 1 is 0. So it totally works. Again, I'll just say generally, you don't have to do things the exact way I'm doing them. I'm just trying to show you the way that I think is the easiest, or at least the most logical, if not the easiest always. You could also probably totally factor the equation that I erased just like by using your factoring skills, which would also be perfectly fine. I just trying to show you a method so that if you encounter a problem where it's hard to just factor it on, so you can go back to the thing we did and be like, oh yeah, we can factor this by grouping, by breaking it up in the usual way. All right, that's all I really have to say about quadratic forms. They're something that doesn't come up a whole lot, but they do come up enough that you should have some sort of plan of attack or method of solving them. I mean, really, depending on the tools at your disposal, you could graph any of those things on Desmos and look for the x-intercepts to find what the solutions were. That would also be legit. Maybe you're not doing the algebra that someone wants you to do, but it's still a way of finding the solutions. Okay, so now for 13 minutes of graphing lines. Maybe 15 minutes. So here's what I want to say about graphing lines. I want it for you to be as easy and fast as possible. Some people, you might want to plot points. If I'm asking you to graph a line, there are only 2 points I ever want you to plot. Maybe only 1, depending on the type of line. But usually there's 2 points, specifically the x and the y-intercept. So there's 2 forms you'll typically be presented with if you're graphing a line, although technically there's a 3rd form as well. But the 2 usual forms are the y equals mx plus b form, which is generally called the slope intercept form. The reason it's called the slope intercept is because if it's written in this form, you can immediately see that the slope is the coefficient there, and the intercept is the number there. And then we also have the standard form. AX plus BY equal to C. And it's called the standard form because any kind of equations where you have variables x and y to raise to some powers, you kind of have this standard way of writing it. So you do like the highest power of x first, and then the lower powers of x, and then the highest powers of y, and so on. So there's a standard way of writing it. But although this is standard, it might be less informative, right? Writing a line like this, although it still is a line, doesn't tell you as much about the line, which is fine. So the method that I think is best for graphing lines is to find the intercepts. So find the y-intercept and the x-intercept, and then just draw the line that goes through them. That's it. So it's kind of like a three-step process. You find one thing, you find the other thing, boom, you draw the line. And I'll show you my try and true method for drawing lines through points that never fails. It's not very exciting, really. Okay, so there we go. Okay. Let's look at this. So we want to graph all the following lines. So we're going to graph y equal to negative 4x plus 12. On your homework, I gave you grid marks. You do not have to use them at all. You could draw your own XY plane, and you might want to, and here's why. Especially if you're not very good at drawing straight lines in the right place you want them to be. So let's find the y-intercept. So I just want to point out, we're on the XY plane. Your y-intercept is on the y-axis. And if you're on the y-axis, what does your x value have to be?
0.
Yeah, big old 0. Right, whenever you're on the y-axis, you've moved neither left nor right, so your x value is 0. So the way we find the y-intercept is by setting x equal to 0. So we do that, and we get y equals negative 4 times 0 plus 12. That goes away, y equals 12. Now, obviously, we already knew the y-intercept was 12 because it's the slope-intercept form. There's the slope, there's the y-intercept. So you don't really have to do the work for this if you're given this form, although you can. X-intercept, the idea is the same. If you're on the x-axis, your y value must be 0. So we're going to set y equal to 0. And this does require a little more solving. Right? We're going to replace, so 0 equals negative 4x plus 12. And we're going to solve for x. We're going to add 4x to both sides. So 4x equals 12, and then divide by 4. So x equals 3. So my intercepts are 0, 12 for the y-intercept, and 3, 0 for the x-intercept. And here's what I really don't want you to do. I don't want you to draw like 1, 2, 3 marks here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marks there, and try to draw the line through those points. I want you to draw the line that looks about right. So I'm going to try and hit 12 up here and 3 over here. I'm just going to try and make this look bigger than that. Okay. That looks pretty good. And then after I've drawn the line, without drawing any hash marks, I'm going to label my points. Seems pretty good. But I don't think you need to draw those little marks unless you really, really want to, which is why using graph paper or grid paper, I think makes this maybe harder, because then you actually have to like try and get it to go through the right value if you want it to look correct. Is this exactly right? Probably not, right? That length is 3, 1, 2, 3. No, like 12 should have been maybe more up here, but sorry, more up there. But it doesn't matter. It just has to look close to right, not exactly right. So that's how we're going to graph lines. That's pretty much it. There's only a couple other things to really say about it. Let's see, what time is it? Okay. Never enough time. So I'm going to do one more like this. So we're going to graph y equal to 3x minus 5. Same deal. Y-intercept. Set x equal to 0. Y is going to equal 0 minus 5, which is negative 5. So we get 0, negative 5 as our y-intercept. X-intercept is usually going to be more work. Not a lot more work, just a little more work. We're going to set y equal to 0. So 0 equals 3x minus 5. You can bring either thing to the left. Let's bring 3x as negative 3x to the left, equals negative 5. And then divide both sides by negative 3 to get x equal to negative 5 divided by negative 3, which is positive 5/3. So my x-intercept is 5/3, comma 0. I'm just trying to be close. Y-intercept is negative 5, so I'm down here somewhere. X-intercept is positive 5/3, which is like 1.66666666. So I know it's on the positive side, and it's not as big as 5, right? It's less than 2. So I know I'm further down and less far over, so maybe it's like that. There's a couple examples I won't do. That's fine, I've got 5 whole minutes. I think I can squeeze in 3 examples. They're fast. Yeah, not you yet. Come back to you. So let's look at a couple written in the standard form. So I want to graph this line. 4x plus 3y equals 6. You can do whatever you want. You can solve for y if that suits your personal choice. But I'm only asking you to graph it. I'm not asking you to find the slope. I'm not asking you to find the slope-intercept form. All I want is the graph. All I need for you to give me are the intercepts. There's nothing that says you have to solve for y here to find the intercepts. So to find the y-intercept, just like before, in fact, this is true regardless of if it's a line or any kind of graph. To find the y-intercept, we set x equal to 0. Okay, set x equal to 0. So 4 times 0 plus 3 times y equals 6. 4 times 0 is 0. So 3y equals 6, divide both sides by 3, y equals 2. And then to find the x-intercept, same idea. Set y equal to 0. So I get 4x plus 3 times 0 equals 6. So 4x equals 6. Divide both sides by 4. So x equals 6 over 4, which reduces to 3 over 2. So my intercepts are 0, 2 for my y-intercept, and 3/2, comma 0 for my x-intercept. And then I can draw the thing. Here, since the numbers happen to be small, I might draw the little marks just because it's only like 2 in this direction and 1.5 in that direction. So in this one case, I might actually draw things. So I'm going to go through 0, 2, and 3/2, comma 0. But even then, I don't think that's really necessary. But the thing that's definitely not necessary is you don't need to solve for y here. You definitely could, but you don't have to. Okay. There is another example like that in the notes. But the last thing I want to show you, just because I know this throws people off sometimes, there are 2 types of lines that only have one intercept. Most lines have 2, unless you're missing a variable. So for example, if I wanted to graph, say, what did I pick here? Y equal to 3. I mean, you can still do the same steps. You can say, okay, I'm going to find the y-intercept. So I set x equal to 0. There's nowhere to put an x equal to 0, but I still get y equal to 3 because y is always equal to 3. I could try to find the x-intercept, but if I set y equal to 0, I have to say no. Y is not equal to 0 because y is equal to 3. So I don't have an x-intercept because y always has to be 3. And to find an x-intercept, y would have to be 0. So here's my graph. Sorry, here's my axes. And then here's my graph. I go up 3. In fact, I could even draw the little marks. Right, there's my intercept of 0, 3. Right there. And then my graph is just the horizontal line through that point. And it can't be anything other than a horizontal line because any line that either tilted this way or that way would have to have an x-intercept somewhere. This one definitely doesn't. You could also say that the slope here is 0 because we have an infinite run and 0 rise, and slope is rise over run. So more generally, whenever you're graphing y equal just a constant, you're always going to get a horizontal line going through that constant value as your y-intercept. And then the same type of thing is true for an x equals something graph. Oh, I should also say here. Here the slope is 0. Last one. I know we're out of time, but I just want to say this last one because there's a couple things I need to say about it. So just real quickly, for example, I won't go through all the stuff, but if our line was, say, I don't know, I want to graph x equal to 4. Same idea. I knew that was going to happen. If I say that I want to have a y-intercept, I'm not going to have one because I would have to set x equal to 0, but I can't because x is equal to 4. And similarly, if I was going to find an x-intercept, well, I can set y equal to 0. Y can actually be anything as long as x is 4, and I get still that x equals 4. So there's my x-intercept of 4, 0. And then I don't have a y-intercept, so I can't tilt that way or tilt that way. I have to be going just straight up and down. So when you have x equal to a constant, it's always going to give you a vertical line. Couple important things about this vertical line versus any other line. This line, x equal to 4, or x equal to just a number in general, has an undefined slope. You have an infinite rise divided by 0 run, and you know dividing by 0 causes problems. And the other thing that's important about this line versus any other line is that vertical lines are not functions. They fail hard the vertical line test, right? So to pass the vertical line test, you have to be able to draw any vertical line that only passes through one point. Well, if you draw this vertical line, it passes through all the points on the graph. So definitely fails, really fails, as much as you can fail the vertical line test. So any other line is a function of x, except for this one, and other vertical lines like it. All right.